In this video, we're going to present some of the solutions to the multiple choice problems selected through the Unit 12 check-in. The first question we're going to look at is question number 3. What is the value of the limit expressed here? And there is this hint, the limit definition of the derivative might be helpful to remember. And that's the reminder that the derivative at some point x is evaluated at the point plus a little bit to the right, minus the value at the point we're considering, and all divided by delta x, with a limit as delta x goes to 0. You can think of this visually for now. We'll look at this formula, and we'll look how it maps onto the ingredients here. We see the delta x already, and then we also see that there's a 2 in this expression we've been given, 2 and 2. And if we map this one more time, we see that f of 2 here is 2 to the 4, and so that indicates that the function we're talking about is x to the 4. Well, that's perfect, because then we can evaluate f prime of x using our normal derivative rules. That'll be 4x cubed, and so f prime of 2, which is exactly what L is here, is going to be 4 times 2 cubed. That's 4 times 8, and that is 32, and that is D as our final answer for question number 3. The next question we're going to look at is question number 5. Again, these are the ones selected from the polling in the final check-in. If you consider the equation given here, it's too complicated to be solved by hand, so we can use Newton's method to solve that. The key thing to remember with Newton's method is the formula, which gives us a new x value based on our old one, refined by this process here. We take the function value at the old value, and we also evaluate the slope at that old value, and that combination gives us a better estimate of the solution. We're told that x naught is our initial guess, so that's going to be our x old, and we're just asked for the next estimate, and that'll be our x new. So the key thing is just to build in the building blocks we have here. We've actually been given a hint in this problem. We've been given f of x. We have f prime of x as part of our requirements, so we're going to take a quick derivative of this. We'll get 2e to the 2x minus 1 and 0. So we have our function, we have the derivative. That means we have all the ingredients we need. X new is going to be x old, 1.5, minus the function value of x old, so putting in 1.5 everywhere here, e to the 2 times 1.5, mark that more clearly as a product, minus 1.5 minus 3. Careful with the parentheses here, it's negative of this whole entire expression, so make sure you have brackets around that. And then the slope, e to the 2 times 1.5 minus 1. Then we pull out our calculators and see what value we get. If we're careful, we end up with a value of around 1.102, and that fits into the categories here of D. Next up is number 6. Here we have an even function, and we're asked which of the following is equal to the integral from -2 to 2. Going back to our ideas about sketching from the live sessions, if we have an even function, then it is something that's symmetric across the x or the y-axis across x equals 0. And so we have the same area here as here. Notice what we have in our ingredient lists are only one that really matches that -2 to 2 and gives us information about 0 to 2. So if we had the 0 to 2 integral and we multiplied that by 2, that would give us the same area as the even function over the longer interval, but only counted once. So what we're looking for there is C. Last but not least, we had question number 8. In this one we had graphs of an original function, and then we were asked for the graphs of the antiderivative. So remembering the relationships, that values on this graph should translate in our diagram that we're looking for into slopes on this diagram. One of the anchors for that are 0 values, and we have 3 of those. 0 values at the start at x2 and x4 should translate into 0 slopes at x equals 0, x2, and x4. So we can look for those first and see what comes out. Graph A, we have a 0 slope, but at x2 we have a positive slope, so that immediately rules out A. For B, we have a slope of 0. At x2 we have a slope of 0, and at x4 we have a slope of 0, so that looks okay. For C, we have a slope of 0, but then at x2 the slope of the graph is positive, can't be C. Last but not least, with graph D, already we're in trouble. At x2 we have a negative slope, that's not 0 slope, so that gives us B as our answer for that problem there. And those are the 4 most common choices from the questionnaire. Hopefully that'll help explain some of the solutions that are in the written and posted solutions online.